Okay, now here's a circle question that starts off nicely enough. It's all just completing the square stuff, isn't it, to find the coordinates of a circle. So I'd start by moving all the x stuff together and all the y stuff together. And because I'm going to complete the square for the x's and the y's separately, I'm going to put some boxes around them. And then I'm going to say, right, okay, I need to halve the coefficient of x. And when that's squared, I don't want the 9 that you're going to get with -3 times -3, so I'm going to take that away. And then we're also going to do the same thing here, so half of 10 is 5. So I don't want that 5, so I'm going to be taking that away in a moment, and then I've got plus 9, well, that 5 squared. Now I'm going to clean this all up a bit, so I've got x take 3 squared. I've got y plus 5 squared. I'm going to have take 9, I'm going to have take 25, and I'm going to have plus 9. They are going to cancel out, so then you're left with x minus 3 squared plus y plus 5 squared equals 25. If we take that over to there, the coordinates are the values of x and y that make these brackets equal 0. So the coordinates are 3 for x and -5 for y, and the radius will be the square root of 25, which is 5. Now, this is where it gets a little bit juicier. It says the line with the equation y equals kx, where k is a constant, cut c at 2 distinct points. So I would start by making a sketch. You can definitely pick up a mark or two at the beginning and get yourself into the question by doing that. I've started it up there because our centre is at 3, 1, 2, 3, and -5, 1, 2, 3, 4, 5. So that's the centre. Now the circle itself is got a radius of 5, so it's actually going to just touch up there, isn't it? And it's going to go, it'll go down to a point of -2, -5, and then it will carry on down there. And we're not too fussed about what that looks like there. What we are bothered about is the straight line. Because this is y equals kx, there's no, the y-intercept is at 0, so we know it's going through there. So I'm thinking that would do it. Anything inside there and anything below there. Now that line there is the line y equals x. No, it's not the line equals y equals x, is it? It's the line y equals 0, because k would equal 0. So anything below 0. So k is going to be below 0. Any negative gradient at all is going to go through there, isn't it? And that's going to cut it. 0 itself won't be 1, because that would hit at 1 point, not 2 distinct points. And then we're looking for 2 distinct points down here. So the discriminant is going to help us to find that. But first of all, we need to simultaneous them by saying, I know that by substituting in to here, kx instead of y. So I'm going to have x squared plus kx squared minus 6x plus 10 times kx plus 9 is equal to 0. So if I just open here, I'm going to have x squared plus k squared x squared, and then I'm going to group my x's. Oh, I've already got them, haven't I? Plus 10kx take 6x plus 9 equals 0. Now the discriminant, if you remember, is what's under the square root in the quadratic formula. So that is b squared take 4ac. Now what's a, b and c? A is the coefficient of x squared. So let's factorize with x squared. What would we be timesing x squared by? We'd be timesing it by 1 plus k squared. And what would our coefficient be here? It would be 10k take 6 for our things, and then we've got plus 9. So A equals 1 plus k squared, B equals 10k take 6, and C equals 9. Right, deep breath, keep going. It's one of those where you just have to trust the process and see what you get out at the end of it. So we've got 10k take 6, that's going to be squared, and we're going to be taking away from that 4 times A, 1 plus k squared, times C, which is 9. And we're going to have all of that equaling 0, because when the discriminant is equal to 0, you're going to have one touching point, aren't you? And so we're interested in, we know that it's going to be, just from our sketch, it's going to be anything more with a bigger value positive than that. So let's see if we can solve this. If we expand that, you might want to use a quick grid. 10k take 6, 10k take 6, that's going to give me 100k squared. It's going to give me plus 36, negative 60k, negative 60k. That's going to take us to 100k squared, take 120k plus 36. Now if we expand all of this, we're going to have 4 plus 4k squared. That's all going to be times by 9. So actually let's just move that in. 9 times 4 is 36, isn't it? So I'm just going to change that to 36 there. And then that's going to give me minus 36, take 36k squared. And all of that is going to equal 0. Right, let's simplify what we've got. 36 from 100 is 64k squared. Take 120k, and the 36 and negative 36 cancel out. Right, let's have a go at solving this for k. Let's move the 120 across to the other side. Right, now I reckon I can divide both sides by k, but I can divide them both by 8 as well, because 8 goes into both those numbers. So that's going to give me 8k is equal to, how many 8s in 120? That's 15, isn't it? So then k is going to equal 15 over 8. And that is going to be the value at which that's just touching there. So we've got our range of values for k is going to be k is smaller than 0 and k is bigger than 15 over 8.